Okay, in the last problem, the wedge was fixed. So the equation, writing the equation was pretty easy. Now let's take a case where the wedge is not fixed. The wedge is moving. We have an arrangement like this: block A, block B, and this is C. And this angle is theta. And it is kept on a horizontal surface which is frictionless, and wedge C is not fixed. Wedge C can move. Now you have been asked, what is the acceleration of A and B and C? It's a good problem. You should really rub yourself with this problem. And if you are able to solve this one right, that means you are done with this chapter. You are damn good in this. You have learned everything. You have spent time and you have earned something. So take a piece of paper and pen and solve this problem, please. Get the acceleration of A and B and C. Okay, I'll give you the answer first. The acceleration of C will be 2 into G into sine theta into cos theta upon 1 plus 3 sine square theta. The acceleration of block B would be 2G sine theta upon root over 1 plus 3 sine square theta. And the acceleration of block A would be 4G sine square theta upon 1 plus 3 sine square theta. So I congratulate to all those of you who have got all three accelerations expression right. I mean, you brought this chapter under your belt, really, if you got all three acceleration under your belt. So you have learned something in physics now. So let's discuss. Again, what you have to do is, you really have to just write Newton's second law of motion, really, and nothing else. Let the acceleration of this block C be C along horizontal direction. And let the acceleration of this block B be B with respect to C down the plane. With respect to C, this B I have not taken with respect to ground. This is with respect to C along the plane, along the inclination. And the question, how will A be moving? Will it be moving only vertically downward, or it will be moving only horizontally, or it will be having the motion in both the dimension? If you draw the FBD of A, if you look at the forces, you have mg downward and normal reaction upward. I told you all the surfaces are smooth. There is no friction between the surface of A and B. So there is no horizontal force of A and B. There is no horizontal force at B. All the forces on A, there is no horizontal force on A, and all the forces are vertical. So A cannot have horizontal motion. So what would happen is B would slide down, A would go towards right, and C would go towards right, and A would just be coming vertically downward. Okay, so A will have no acceleration in horizontal direction. So A would come vertically downward. Let that, with an acceleration, let that be A. Now, second question, if I ask you, how did I assume, or why did I assume that this block wedge will be going towards right? How do I get that feel? Why didn't I take C in the opposite direction? Even if I would have taken C in the opposite direction, that would have not hampered my answer. My answer would have come with a negative value, as it would come in this case. But why did I take the wedge acceleration towards right? Because if I look at the FBD, you have mg and you have normal reaction, and at this contact you have a normal reaction in this direction, because B by its weight would be pressing wedge C. So normal reaction for C would be downward, like this. This is the vertical forces. They have nothing to do with the motion in horizontal direction. But if you break normal reaction into vertical and horizontal component, then you see from there that the normal reaction has a horizontal component towards right. So the wedge C would be moving towards right. Okay, so you have to make it a habit of thinking from FBD. That make things simpler and easier. Okay, now let's write Newton's law of motion for the entire system. For the entire system, if you write Newton's law of motion in horizontal direction, then there is no net external force in horizontal direction because no force is applied. Nobody is applying any force. The system is on its own. And the normal reaction, that is internal force acting both on B and C in opposite direction. So there is no net external force. So net external force is 0, which will be equal to mass into acceleration. Mass of C into acceleration of C. That is for block C. Plus mass of B into acceleration of B. I have taken right side as positive direction. Now B, this is net acceleration because we are talking about net external force. Now net acceleration of block B in the horizontal direction, it has a B acceleration with respect to C and it is moving along with C. So with respect to ground, it has an acceleration vector like this, B and C. Now in the horizontal direction, it has a component of B. And this angle is theta. So in the horizontal direction, it has a component C minus B cos theta towards right. And A doesn't have any acceleration towards right because all its acceleration is vertically downward. So you'll have mass into acceleration of A, which will be 0. This is mass into acceleration. This should be equal to 0. This should be equal to net external force, which is 0. So from here, we'll get 2C is equal to B cos theta. So this is one relation. Good. Now for the other relation, you have to write Newton's second law of motion for some other body in some other direction. So let's write Newton's second law of motion exclusively for body C, for body B. We have written for the entire system. Let's write Newton's second law of motion for body B. For body B, if you see the FBD, there's mg downward and the normal reaction from this contact is perpendicular to the plane inclination of the wedge, and there is a normal reaction from this contact between A and B. So there are three forces acting on B. So let us write Newton's second law of motion in the plane of the wedge. So in the plane of the wedge, this normal reaction has nothing to do for the motion because it is perpendicular to the plane of the wedge. So along the plane of the wedge, you have two components of mg and components of normal reaction. Component of mg would be mg sine theta and component of normal reaction will be n sine theta. Easy to look from geometry. I'm not going to teach you this now. Mg cosine theta plus n sine theta is the net force on block B down the plane. This should be equal to mass of B into acceleration of B. Acceleration of B down the plane, net acceleration. So from here you will see this is the B vector and this is C vector. In the ground frame, this is the acceleration of B. So acceleration down the plane is B minus C cos theta, net acceleration in this plane. Okay, so B minus C cos theta. Fine, so we have written the equation of motion for block B. Now, for block A, let's write the equation of motion. For block A is moving towards in the downward direction. So net force for block A in downward direction is mg minus n. That should be equal to mass of A into acceleration of A. Now, the acceleration of A would be A, but there's a relation between A and B. Now, what is that relation? The relation is the block B has two components of acceleration. C is horizontal and B is down the plane. Now, A and B will never lose contact. So with whatever amount of distance B is coming down, by the same amount of distance A will also come down because A and B are never losing contact. B will slide towards left as well. A is not going to do that because A doesn't have any force in horizontal direction. But when A is sliding left and down, when B is sliding left and down, then A is also going to come along with B because A will not lose contact with B. So whatever acceleration B has in downward direction, A also has to have the same acceleration in the downward direction. So the acceleration of B in downward direction, as you can see, this angle is theta, is B sine theta in downward direction. C is horizontal, there will be no component of C. B has a component B sine theta, this component, in vertically downward direction. So the acceleration small a will be same as B sine theta, because A and B are not losing contact. So from here we replace n and put here. So what we get is mg sine theta. Normal reaction from here would be mb sine theta. No, normal reaction from here would be mg minus mb sine theta, and we put that normal reaction here. Okay, so from here you can see that what are you going to get? You're going to get 2mg, or let's cancel m, all the m. So from here you have g sine theta and g sine theta. So you're going to get 2g sine theta plus c cos theta is equal to b into 1 plus sine square theta. Fine. So what you're going to get from here is, let me rub this off. Okay, so B you have got. So B would be from here in terms of C. From this equation you get B in terms of C. And remember, from the first equation, what did we have? We had 2C is equal to B cos theta. Fine. So if we replace from here B and put there, what we would get?